Hi, welcome to question 10 of the Leaving Cert Ordinary Level 2025 Paper 2. So we'll get stuck in, and initially this is kind of an area volume question. And we'll read through it as a 10 marker. Ava is a member of a sea swimming club. The club has 6 markers in the water labeled A, B, C, D, E, and F, as shown in the diagram below. So we see A to B is 200 meters, B to C is 150, C to D is 200, D to E is 150, E to F is 200 meters, and F back to A is 200 meters. They give us a shaded region here with an angle of 110, so trigonometry, geometry. Now part A says ABCDEF is a 6-sided shape where AF is parallel to CD. So this line here is parallel to this line here. And AF is perpendicular to AC. So AF is perpendicular. So that creates a 90-degree angle, okay, because it's perpendicular, which means this is likely a square, okay, in the middle. Maybe not a square actually. It's maybe a rectangle. Whatever, we'll find out. AB is equal to the length of CD. So let's see, AB is equal to the length of CD, they're both 200, which is equal to EF, which is equal to, that's EF, which is equal to FA. So they're marked on the diagram, all are 200. BC, this one here, and DE are equal, and they're both equal to 150 meters. Okay, there's restatements on the diagram. Now, part 1 says Ava swims from A to B to C to D to E to F and back to A. Find the total distance Ava swims. Now, lots of words that can be confusing, but ultimately you're adding up all the distances together. Okay, so the 200 plus the 150 plus the 200 plus the 150 plus the 200 plus the 200. Once you put that down, and always do show that calculation, put it through your calculator. I got an answer of 1,100. Now, initially I accidentally put in centimeters there. I put in the wrong units by being whatever. Just make sure you kind of, it's a long swim, so make sure you put the units in to indicate that. Now that's part 1. Now part 2 says the size of the angle ABC is 110 degrees. So that's this angle here. Work out the area correct to the nearest meter squared, so we have to round it, of the triangle ABC. That is the area of the shaded region in the diagram above. So I've kind of drawn it out there separately, and so it's always worth doing a pilot diagram just to help your brain make sense of what's happening. This is not a right angle triangle, okay? So the area is equal to half base by height would be not able to be used or trickier. The formula that might make most sense here is the formula we might learn in trigonometry, which is a half times A times B times sine C. Now I just memorize off this one version. There's 2 other versions depending on the labeling, and I relabel based on what I need. So I'm going to call this side here A, okay? I'm going to call this side here B. I'm kind of ignoring their labeling, okay, because they're saying this is angle B. And then the angle in between, the C is 110. So this formula initially has 4 things. I know 3 of the 4, it is solvable. So I substitute my values instead of the letters and put that through the calculator. I got an answer of 14,095.38, whatever. But the question does say round that to the nearest meter squared. The 3 is what matters. The 3 is less than 5, so the next number stays the same. The answer is 14,095 meters squared. And again, I include the units. And that's it. So a nice handy 10 marks if you're familiar with using this formula and can interpret what they're asking. Now, Ava swims straight from A to C. Okay, she takes that maybe a shortcut, whatever. Now, they're being very specific here. They're saying use the cosine rule to work out the distance from A to C. Correct your answer to the nearest meter. Now, the first thing they're telling you what to do. So I'll go find the cosine rule in the maths tables and write it out. And you'll see here there's 1, 2, 3. Now, B and C are repeated. So there's 3 things plus the angle A. There's 4 unknowns. If I know 3 of those 4 things, I can solve this. Now, if I look at the diagram, okay, I know, and the side A, we often say, is the side opposite the angle I have. We need to know the 2 sides either side of it. I'm looking for what A is. Do I know a B value? I do 200. Do I know a C value? It's 150. Do I know the angle in between? And I'm going to call that big A, which is arguably different than what I did in part two. So I'm kind of redrawing it or relabeling it based on my needs. Okay. Now, once I realize I have three of the four things, I can substitute them in, and it gets a bit crazy here. We have a calculator. Okay, so just program this whole thing in the calculator. I got an answer of 83,021 plus change. Now, one thing that's very commonly forgotten here is that this formula is a squared, not a equal to. So I need to deal with this square, and I'm going to bring it across to the far side. When you move anything across the equal, it changes into its opposite. The opposite of squaring is a square root. Put that through the calculator. I came out with 288.134. It does say corrected nearest meter. The 1 is what matters. 1 is less than 5. The number before it stays the same. And I put in my units. Now, if I got an answer of 83,021 meters, that's 83 kilometers. Now, that's, from the vast majority of people would be outside the range that they could swim. Make sure you put all the answers, especially for trigonometry and geometry, if they're real world, put it through what I call the BS meter. Does it make sense? If it doesn't, just double check. You may catch that you didn't square root the answer. 288 meters seems much more reasonable, especially based on the diagram. 82,000 wouldn't have made sense. Now, part 4 says, hence or otherwise work out the total area of the water enclosed by all the 6 markers. Now, it mightn't be obvious, but this triangle here and this kind of imaginary triangle here are the same size. Okay. So we know from the previous answer that this here is 288, which will be useful in a second. But the area of CBA, which we just found, okay, is equal to 14,095. That's our previous part. The area of the two sides together, okay, the two triangles, is just add them or multiply by 2. Okay, I'm adding them and I got 28,190. But I'm missing this little bit in the middle. Now I can find the area of that by using length times width, which works for a square or a rectangle. The length is, we'll say, 200. The width is 288. So I multiply them together and I got 57,600. Now, we want the total area. So we're adding those numbers, the two triangles and the rectangle in the middle. Okay. I come out with a final answer of 85,790. And again, the units are meters squared. Okay. Now we're moving into probability or number systems kind of thing. I struggle with these. I've gotten better at them over years, but they can be tricky. Okay. Now we'll read through part B, part 1, which has got the 10 marks. 2 and 3 were combined together on the marking scheme and are only worth 5 marks. So our part 1 here is going to give us the best marks for this particular exam on the marking scheme. Now it says point A is the nearest point to the shore and is the start and end point for all swims. And we see here that they're giving me the diagram again with less fluff on it, and they're giving me a start and end point. Ava wants to see how many routes she could swim, starting at A by swimming to each of the 5 markers, B, C, D, E, and F, once and only once, and always finishing back at A. For example, Ava could swim A to E, to C, to F, to D, to B, back to A. And she's only done each thing once. Now, part 1 says, give another example of such a route Ava could swim. And this is where you spend a bit of time. Did I put the answer in? She could go, and there's multiple answers to this. She could go A to F, to E, to D, to C, to B, to A, which kind of feels like cheating. You're kind of going, that's on the diagram. But it satisfies the requirements they had. Okay. Now, part 2 says, where we're back into the 5 marks here, and part 2 and 3 are marked together, work out how many such routes are possible. Okay. Now, there's different ways of doing this. When she makes her first swim, she has 5 choices. And now she has 4 choices. And now 3 choices. Because you've used up 1, you've used up 2, whatever. And 2 choices. And finally, there's only 1 choice left. Now, I've said the and over and over again. And in the and scenario, you multiply. Okay, so we're multiplying 5 by 4 by 3 by 2 by 1, which is basically 5 factorial, and that gives me 120 roots. Okay, so that's probably the most common way of doing that. It's called the box method. And to me, it makes intuitive sense, you know. Although probability can be, you know, this is kind of in the realms of probability, can be kind of counterintuitive sometimes. So that's probably why the marking scheme was only given 5 marks. It maybe wasn't very well answered. And it is a kind of tricky question. This once and only once thing kind of got me the first time I saw it. Now, part 3, which is marked for part 2. On a particular day, Ava wants to start at A, swim to 2 markers other than A, and then return to A. For example, Ava could swim the route A to E to B back to A. Work out how many such routes are possible. Now, doing it, you can maybe do it by hand, like just try and error and just working it through. But the answer would be simply that there's 5 choices initially. Okay, then there's 4 choices she can make on the second marker, and then back to base. Okay, so she had 5 choices and 4 choices. 5 times 4 is 20. Again, there's other ways of doing that. There's the permutations and combinations is where this is coming from. That might just be the simplest way of doing it. Right, that's the end of the paper 2 for the Leaving Cert Ordinary Level 2025. As always, if you want a copy of the notes I'm working off, send me an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. Best of luck.